Okay, so let me go over this. -2 is my x. So if you want to know how to show work, you go like that. There's the -2 because it's my x. I go up to 1, boom, that's my y. Play the same game for the 3. 1, 2, 3. Oh my gosh, I'm already there. 0. This time, for this one, I'm saying the y is 3. 1, 2, 3. So if I go over, I do 2 leaps over, and that's x equals 2. Don't forget the x. Name 2 points where the y value is repeated. If you look here, right there, the y value is repeated. So -2, 1, and 1, 1. All right, given the following points, fill in the table and graph each of the new functions. Okay, so they don't care about graphing this part, just graphing the new ones. So what I'm going to do is I'm going to take the -2. It's written a little bit differently. This is like f of -2 equals 5, f of -1 equals 3, so on and so forth. So I take f of -2, which is 5, then I add 3 to that, and that's 8. So I'm taking the y values. So I'm doing f of -1, which is 3, add 3, 6. F of 0 is -1 plus 3, 2. F of 1 is -4 plus 3 is -1. F of 2 is 0 plus 3 is 3. F of 3 is 6 plus 3 is 9. Now, this time what I'm doing is I'm taking half of the x value to then find the y value. So -1/2 times -4 is positive 2. There's positive 2, the y value is 0. Half of -2, or -1/2 of -2 is positive 1. The y value is -4. Half of nothing is nothing. The y value is -1. -1/2 times 2 is -1. The y value is 3. -1/2 times 4 is -2. The y value is 5. -1/2 times positive 6 is -3. There is no -3 here, so that would be a no solution. Okay? I'm going to graph them. Left 2, up 8, right 1, up 6, 0, 3, 1, -1, 2, 3. Honestly, you know what? I don't really like this. I'm just going to say, I'll make sure I do this for the test. Don't worry about graphing the new functions. Let's just graph the original, please. This is ridiculous. It's too much plotting points. So just take the points. We're going to negate all those. -2, 5, -1, 3, 0, -1, 1, -4, 2, 0, and 3, 6. 1, 2, 3, and then up 6. I feel like that's just the easiest. So I'll make sure I change that for the test. Just graph the original. Okay, it says represent the mapping diagram, but this is a table, so I want you to represent this in 2 different ways. Okay, so this is a table. I want to represent it in 2 different ways, so I'll play a mapping diagram as one of the ways. Don't write the same thing 2 times. 1 goes to 0, 3 goes to 4, 5 to 8, 7 to 12, 7 to 16. So that's a mapping diagram. I can represent it as a set of points. Let me write that. Mapping diagram. Okay, points. 1, 0, 3, 4, 5, 8, 7, 12, 7, 16. Set notation. I could have also done domain and range. Okay, page 1 done. Page 2, describe the transformation. All right, so this right here means, and I'm not going to write it out, I'm just going to initial, but you need to write it out. Vertical translation 7 units down. So that's the 7. The 1/3 is with the x, which really means it's the inverse, 3. So that means it is a horizontal stretch by a factor of 3. Okay, let's look at this next one. This 4 is with the x, so you do the opposite. Horizontal translation 4 units left. The negative means a reflection. It's with the y, which really means it's with the x. Reflection over the x axis. Okay, so they want me to make a new function. So if the parent is f of x, I need to make sure I write g of x, h of x, whatever. Okay, vertical stretch by a factor of 3. Oh, and by the way, it's a squared, so I want to make sure I do my squared. Reflection over the x really means it's with the y. Horizontal compression by a factor of 1/4, but that means it's really multiplying by 4. And then vertical translation 4 units up. So that means this is just going to be 4x. Okay? All right. Give me a second to read this one. Okay, so as I read it, what they're trying to do is they're trying to see if all these transformations turned into this function right here. So g of x, because it's a new function, it's a linear function. It says horizontal stretch by a factor of 4, which really means that you're going to show it as the inverse 1/4 in parentheses. Vertical translation 1 unit down, -1. And then reflection over the x really means it's with the y, which is the whole thing. Excuse me. So that's negative. So that turns into negative 1/4 x plus 1. Now I need to see what this is. Okay, the start is at 1, and it went down 1 and right 4. Down 1, right 4. So y equals negative 1/4 x plus 1. They are equal, so yes, she's correct. Okay? Oops, I'm sorry you didn't see that. All right, factoring. There's 2 of them. You can square root both. Square root of 16x squared is 4x. Square root of 225 is 15. 1 gets a plus, 1 gets a minus. This one, d. Think of all the ways to get 56. 1, 56, 2, 28, 4, 14, 7, 8. We're trying to add to get negative 1. Boom, that works. Since this is negative, the bigger number is negative. And I'm done. Okay, this one they all have something the same, so I can separate it. 5, 5, negative 5 times 1, 5 times 2, 3f's, 2f's, 4f's. So I can circle 2 of these f's, a 5, which leaves me 5f squared. And then I see I'm left with 5f minus 1 plus 2f squared. Now you feel like this should be right, but this part is not in standard form, so I need to rewrite it so that the f squared comes first, then the f, oops, so 5f, then the 1. Okay. D is similar to B, where I think of all the ways to get 15, 1, 15, 3, 5. And then I list all the ways to get to 2, which is 2y and y. And now I'm just doing guess and check. So I'm going to do a 5 here and a 3 here. This gives me 5. This gives me 6. When I subtract them, I can get a 1. So I got lucky. If this is positive, the bigger guy's positive, which means this one's negative. So that's minus. That's plus. And there's my answer. I didn't use 1 and 15 because the middle guy's a small number, so it just didn't feel right. Okay, I can't square root. It doesn't look like B or D, but I notice they have something the same. 3 times 16, negative 3 times 1, CC. Circle the 3's. 16 minus, I don't want the 1 because I have the C's. Now I need to see square root, bring down the 3. 2 sets of parentheses. Since the 16 comes first, the 4 comes first. C comes second, don't forget the 3.